Hello and welcome back everyone to yet another lesson in Python programming. The focus of today's lesson is working with data visualization tools such as Matplotlib. With that said, let's have a look at the objectives for today's lesson. Now the objectives for today's lesson is as follows. First, we'll briefly discuss the importance of the Matplotlib library. Next, we'll move on to exploring the applications of Matplotlib. And finally, we'll use the library within a practical demonstration. So first of all, what exactly is Matplotlib? Well, in essence, Matplotlib is a popular data visualization library for the Python programming language. It provides a variety of functions and tools for creating high-quality, customizable plots, charts, and other visualizations of data. Matplotlib can be used to create a wide range of visualizations, including plots, scatter plots, bar charts, histograms, pie charts, and so many others. It can also be used to create more complex visualizations such as 3D plots and animations. The library is widely used in many different fields, including scientific research, engineering, finance, and data analysis. So, what makes Matplotlib so special, and why should you consider using it within your environment? Well, first of all, the obvious for data visualization. Matplotlib is a powerful data visualization library that allows you to create a wide variety of visualizations to explore and analyze your data. Secondly, it allows for Python integration. Matplotlib is designed to work seamlessly with the Python programming language, which is one of the most widely used programming languages in data science and machine learning. When it comes to career opportunities, Matplotlib is also quite important. Data visualization is an essential skill for so many different careers, including data analysis, as we've just mentioned, business intelligence, and data science. By learning Matplotlib, you will be better equipped to create compelling visualizations that communicate insights effectively. And lastly, Matplotlib does have a huge community and a lot of support. It has a large and active community of users and developers, which means that there are many resources available to help you learn and troubleshoot any issues that you might encounter. Now, here are some really great features of the Matplotlib library. The first is basic plotting. This includes creating a figure, creating subplots, plotting data using various types of plots, such as line plots, scatter plots, bar plots, histograms, as well as box plots. It also comes equipped with advanced plotting, which involves options such as 3D plots, polar plots, heat maps, contour plots, and image plots. Saving and exporting plots is yet another amazing feature. After creating a plot, it's important to know how to save and export it to various file formats such as PNG, PDF, and SVG. In addition, it's important to know how to display and save multiple plots in the same figure. And finally, it also allows for interactive figures. Matplotlib provides several options for interactive plotting, including using the MPLD3 library, which generates interactive HTML plots that can be embedded inside of a website. Some examples of some of the most basic graphs in Matplotlib include the following: histograms, bar charts, scatter plots, as well as box plots. Let's take a look at what the code would look like for creating a graph in Matplotlib. First, we import the library and rename it to PLT. Then we set the values for the X and the Y axis. In the case of these values, we are using arrays. After which, we call the plot function and plot the X and Y axis. And lastly, we show the actual graph. And this is what this code example looks like. The great thing about Matplotlib is that we can use just a few lines of code to create really interactive graphs. And now that we have a basic understanding of the Matplotlib library, let's dive into practical demonstration and let's start coding. Now, in order to get started with Matplotlib, we first have to create a new project, much like we've done in the background over here. The next thing we want to do, like we've done in the previous lesson, is to install the actual library. So I'm going to do pip install matplotlib. And do keep in mind that I am doing this through the command line interface. And if I run this now, I already have the software or the library installed. So therefore, it's going to note that the requirement is already satisfied. However, in your case, if you've not installed Matplotlib yet, you first have to go in and run the specific step. Great. Now with Matplotlib being installed, I can start scripting. So over in my interface over here, I'm going to write from Matplotlib import the pie plot package, and I'll import this as PLT for a shorthand. Great. So now that we've installed, or now that we've called the package and the library into our environment, we can start with the actual code. What I'm going to do is I'm going to copy and paste quite a bit of code, at least just in terms of the data that we are going to be working with, and that data will plot on a graph. So I'll start with the first one, and I'll get the x-axis value that I want to work with. So notice that I have a variable called x over here, which stores the years 2010 up until 2023. The next step is to create the y-axis values. And the values that we are going to be working with here will be y1 and y2. And these values are actually the price of Bitcoin since the year 2010 up until 23, and the price of gold, which has been allocated to y2 from 2010 up until 2023. Now, just in case you're wondering where it is that I retrieved these values from, I used two online websites. The first is in2013dollars.com. And in this website, or /Bitcoin-price, and on this website, you'll notice that we have a table over here, which gives you the price of Bitcoin since 2010 up until 2023. Also notice that the prices over here are from the 1st of January of each year. So for gold, I managed to use the gold.org website, where I simply just changed the filter over here, and I was able to more or less get an idea of the price of gold over X amount of years. You can even use the max filter over here, and this will give you the price since 1973 up until 2023. So what I've done was, just to make sure that the data is somewhat equal, I tried to retrieve the values of the price of gold as close as possible to the 1st of January year over year from 2010 up until 2023. So now that I have my X and Y values, I'm simply going to start scripting by calling fig for fig, and this will allow me to convert the data over here into an actual figure. So fig, comma, or figure, and then I'll create a new variable called ax1. I'll set this equal to PLT, which is the Matplotlib shorthand we created at the top over here, and I'll call the subplots function on this, and this is because I'm going to map in my graph multiple lines or multiple series. On a new line, I'll create a variable called ax2, and I'll set this equal to ax1, after which I'll call the twin x function, and this is because I'm going to have multiple lines on my graph. On a new line over here, I'll call ax1 again, and I'll say dot plot the x and the y1 values. Now, I also want to give this specific line a specific color. So I'll call color over here, which is a property, and I'll set this equal to G, lowercase, which will be a string for green. And let's just clean this up a little over here. And then I'll move on to a new line, and I'll say ax1 again, and I'll call the dot plot function on this, and I once again have to provide specific parameters over here. So x, and then I'm also going to plot y2's values, and I'm going to give this one a specific color as well, and I'll call color, and I'll set this equal to B for blue. Great. So now we also want to set our labels. So I'm going to call ax1 again, and then I'll use the set label function over here, set x label, and I'm going to give this label the value of year. So over here, I'll call year, and then I'll copy and paste this a couple of times. I'll maintain ax1 over here. I'll call the dot set y label over here, and I'll call this one Bitcoin. And then I'm going to provide additional properties. Color, in this case, I'll set this equal to green. And then for the last line over here, instead of calling ax1, I'm going to call ax2. So ax2, and maybe I should just zoom in slightly. There we go. And for this specific property, I'm going to call color again, and I'll set the color here equal to blue. And that is it. We also want to change the label over here, and I'm going to change this to gold, And the final thing to actually do is change this from X label to Y label, because we want to plot Bitcoin and gold on the same chart. Great. And all we have to do is call PLT, and I'll call dot show function. Great. And that's basically it. So let's run our code and see what we get. Exactly as expected. So we can actually see, just by passing in a couple of arrays with a x-axis and two y-axes over here, we can plot all this data on our chart, where gold is the blue line and Bitcoin is the green line. So what can we infer from this? Well, we can simply infer that from 2010 up until roughly 2014, 15, or even 16, the price of gold had surpassed the price of Bitcoin up until roughly 2017, where Bitcoin started to exceed the price of gold. By looking at this graph, we can also tell that Bitcoin's price is quite volatile. And that is simply because we have these major upswings and then these major downtrends, and we might just experience another major upswing and a major downtrend. At the end of the day, up until 2023, we can still note that the price of Bitcoin vastly exceeds the price of gold. While Bitcoin is quite volatile, we can also infer that the price of gold tends to be a lot more stable. However, the price of gold does seem to increase very, very slowly. And this is how we can use very, very basic Matplotlib library functions and features to demonstrate our data visually. However, there is one small issue. What if I did not want to hard code my values like this? What if I wanted to extract the data from an external file like a CSV file? Well, you could certainly do that, and that would be the better way, I would argue, simply because hard-coded values when it comes to data is not always a great idea. It also requires a lot of time to compile these arrays, for example, whereas working with a CSV file where data might have been exported from a system can be a lot easier to work with. Now, with that said, I think this is a fairly basic example that one can use to understand how Matplotlib actually works. So what exactly have we learned? We've learned that we can use Matplotlib for data visualization, especially if we are compiling our data inside of our IDE using hard-coded variables. We can also optimize the properties and some of the functions of our graphs if we wanted to. Now, do keep in mind that this is just one example. There are so many other charts that one can create using Matplotlib, and we can even create very, very complex charts. In our next lesson, we're going to try something very, very similar, but instead of working with hard-coded data, we're going to extract data from a CSV file. So for all of that and more, I'll see you in the next lesson. Cheers.